All right, the broadcast is on. Hello and welcome to your weekly webinar number 5 with Michael Floyd. I am your mentor and your mentee. You learn as much from me as I hope to learn from you. So, a couple of things I want to get out. Okay, the filling out the introduction from the beginning. I know I did not do that initially, but I still need everybody who has not did it with me to complete this form. So 5 out of 14 of you still have not completed that. I would like for you to set up a meeting with me tomorrow or Wednesday, and we can get that done as quick as possible. Okay. Now, for setting the pace for this course, I would say for a lot of you, we are in a state of an emergency. So looking at it, 10 out of 14 of you guys have not completed the first project yet. Okay, I mean, just remind you guys, the money is already spent. Okay, so whether you complete this or not complete this, you know, it's entirely up to you. But the money is gone, and I would prefer you walk out of this program in the next half a year or so with a completion as far as data science, so you can be able to get that job, university, wherever you were going, whatever requires you or to do this, or if it's just for background knowledge. But yeah, 10 out of 14, I'm hoping we all get this done. And, you know, as far as I said, you know, 30 minutes in the morning, 30 minutes at night keeps your mind at a constant state of freshness and, you know, with the material. So that's something that I would consider doing, especially if you are off track. And, you know, for a helper for you guys that are on track, every time you spend time doing this, just, you know, post in Slack in your group, hey, you know, just completed this lesson, just completed this lesson. I learned this and this. Not to be quick. I mean, it doesn't be long, but, you know, quickly just state this so we can keep the Slack channel going, and possibly some people can also see your questions. I know we all must have questions because, you know, everybody is not up to speed. So hopefully we come out of that shell and begin asking questions on Slack. Okay. All right. Now for this webinar, what I'm going to show you how to do is set up a GPU on Amazon Web Services. So just in case if you may run out of time for your image classification project, or you want to train a machine learning model yourself or deep learning model yourself sometime in the near future, I can show you how to get an instance up and running. You can see it on your computer, and how to transfer files and whatnot in a easy manner to and from your instance. Okay. So with that being said, let me begin sharing my screen. All right, so I'm presenting my screen. Now, the first thing you must do is, of course, get an Amazon Web Services account. And once that account is up and running, the next thing you must do is request access for the instances you will be using, just in case you do not automatically have access. I believe for the instance like the P2 large, which I will be showing you how to activate, I believe you must request permission to launch that instance from Amazon initially. But once that permission is granted, then you can rip and run and launch these instances. Okay, but okay, so what you're going to do is you're going to begin. All right, you have an Amazon Web Services account. So I was just clicking on the home thing. So you're going to have a console. Your console is going to look something similar to this. You're going to see the services you recently visited. If you have not recently visited any services, then you can just go to all services and compute. Under compute, you have your EC2 instance. EC2 stands for Elastic Cloud Computing. Click on that, and that is where you're going to launch your instance, which is just a separate computer somewhere that you are able to access and make it do things for you. In this case, we will be using that computer to train our models on a GPU, because we need a GPU. A GPU is faster than a CPU, and the instances are relatively efficient. And so what I did is I just clicked on, in case I hopefully did not go too fast just now, but what I did is I clicked on Launch Instance. Okay, you can also go to your Instance tab. This is your Elastic Cloud Compute dashboard. You go to your instance and click Launch Instance, or you can launch your instance. Okay, so as you can all see, I have 0 running instances so far right now. So now your Amazon machine image. In order to quickly be able to begin using the GPU and using the software that you would need, you could have images already attached to your computer that you will be getting from AWS. So, of course, it'll be easy to have a machine that already has Python and PyTorch and Jupyter Notebook and all these good things that are already in place and installed for you to use. So the instance, the machine image we will be looking for is just type in deep learning and Ubuntu, click enter, and also click under the AWS Marketplace. That is where you will want to be looking. So we have deep learning AMI for Ubuntu. As you can see, it has TensorFlow, MXNet, PyTorch. You can look under more, but so it has PyTorch. So we are all right with the deep learning, this AMI. So we will select it. And these are the pricing details. This is, if the marketplace image would have an additional cost to the costs that are already incurred with the EC2 instance, it is letting us know. The good thing is this marketplace image has 0 costs attached to it, so we can use this for free. And then plus we will pick out our EC2 instance, and these are the pricings that are there for the EC2 instance. It usually does not pop up unless you're using a marketplace. But if you want to know the pricings, you can always just click AWS pricings EC2 instance, and Google search that. The first thing comes with the EC2 instance pricing, and you will get a list of the pricing. So that's, I'm going to exit out of that. I don't want to go through that. So you just click continue, that you understand. And what we're going to be looking for is a GPU instance. Many different types of GPU instance. The one that I use most often is either the P2X large or the P3X large. This would not be a big computing that we are doing, so P2X large is good enough. You have 61 gigabytes as far as memory in your GPU instance, and attached to 4 CPUs. So this is definitely good enough for just this demonstration. We have configured the instance. Everything here is good. We are only starting 1. We have our network. You can create a new virtual private cloud or do it on this one. This is just the default. This is all right for now. Don't need any subnets. This is not going to be attached to any other AWS services. Everything here is good. for now. Is you can add more storage if you need to. The tags you can add, a key and value pair for your tags. And here you're going to be configuring your security. So that means what can go in and out of your network. And we're going to add a rule here. And because Jupyter Notebook runs on the port 8888, we're going to be adding a rule for that to run from the port. Select anywhere. You can leave a description here just to make sure we know why we are adding this. Okay. And the HTTPS rule as well, and anywhere will work for that. And okay, so now we're going to review everything. Should look fine. And now we will click on launch. And so we will want to create an existing, well, you will want to create a key pair because this is with this tutorial. So we will just assume that a key pair is not created. Okay. So you would select create a new key pair, and let's call this key pair data science, well, DSND for DS nanodegree, and demo, because I did this before with another file called DSND. So DSND demo, click download key pair. The DSND demo is going to download a .pem file. That is going to give you access into your instance. Now you're going to launch the instance. It works similar to a password would do. So while that's launching and while all that's getting set up, that's done, you can click on view instances. Now, so now you're back on the dashboard, and now it's going to take you to your instance tab. And as you can see, we now have an instance, but it's still pending. So it's loading, getting everything ready. And while that's getting ready, what we're going to do, a couple of things we need to do. One is we need to download PuTTY. So if you just go to download PuTTY, Google search it, go to putty.org and download PuTTY. That's one thing you need to do is that just click download PuTTY here, and also download WinSCP. So it's two things you should download, that will help you along this journey. Is download WinSCP and download PuTTY. So here it is. Just download both of those things. All right. And so assuming you've already had the WinSCP and PuTTY downloaded, you can go into your files. Now in PuTTY, what we're going to be using is the PuTTY gen. So what we're going to be doing is generating a private key that can be used with PuTTY. And so we're going to be loading an existing private key file. Just click on load. And go to our downloads where we have our demo PEM file. We're going to be search data science nanodegree demo. Also, because I'm going to look for private keys, we're going to be looking for all files. And here it is. We're going to click on it. We want to save it as a private key so it can be in PuTTY's format. It's in a PEM format. Okay. We're going to click OK. And now since we have this key loaded, we're going to save this private key. And we're going to save without a passphrase. We don't need a passphrase. And where we're going to save it at is in a nice place. Save this in a nice place. So data science nano degree demo. I'm going to save it as that and click on save. So now we have our key. We can, now that our private key is generated to be able to be used with PuTTY, we can now use PuTTY. So we're going to close out of this generator. Close out that as well. And we are going to log in to PuTTY. So we can log into the instance using PuTTY. So now we have our host name or IP address. Let's look back at our instance. It is still pending, but we can find our public domain name. So that is our host name. We can just copy this, paste that. Okay, that's one thing you need to do. Another thing you need to do is make sure that you can use your private key files. So under connections, SSH, auth, which is authentication, you're going to have a place where going to be actually for your private key file for authentication. You can browse, click on what you saved it under, data science nano degree demo. Okay, so now that's in line. The only thing left is the tunnels. You want to make sure you can access Jupyter Notebook from your computer. So our source port is going to be 8888, and our destination is going to be 127.0.0.1.888. Okay, and this is just for standard Jupyter Notebooks, so it's going from the instance to the computer. And let me make yes, just making sure that is correct. Okay, so you also need to do that as well. So do those three things. You should be good for takeoff. And also before you load this, what you want to do, so you have to do this every time you open a session using PuTTY, we can save these sessions. So let's save it as data science nano degree demo and save this session. So now that these sessions saved, if I exit out of here, I go back to PuTTY. And I just click on data science nano degree demo and I press load. Everything is there, right? The same domain name, the IP address, and the same, well, everything else is there as far as the authentication and whatnot. So all I'll do is click open. It's going to say, hey, it's we've never accessed the server before. If you trust it, keep going. Press yes. Log in as the name. Username is Ubuntu for this machine image. So Ubuntu is it. And now you are into your computer or your instance. Now you're into your instance from AWS. Okay. So the other thing I wanted to do is, well, now that you're into your instance, let's begin by running Jupyter Notebook. Jupyter Notebook, press enter. And while all that is loading, what I'm going to do is open WinSCP. Here's WinSCP. Notebook still loading. What we're going to be doing with WinSCP is taking all the files that we need from our nanodegree program and new site. Our host name. Remember, our host name is the what we get from AWS. So we can copy this host name and using WinSCP. I have two open. Okay, I have one open now. All right. So our host name and the port is still the same. The username is Ubuntu. And before we begin, we're going to click on Advanced. All right. And under Advanced, we're going to go to Authentication. And the same thing as before, we need to make sure that our authentication works similar to these private keys work similar to a password, right? Nobody can access your instance without the private key file, and you're the only person that now has the private key file. So here that is. Everything else is good. Click OK. We can save this instance, and the name, let's give it a better name, data science nanodegree demo, and okay. All right, so now it's logged in here as well. Everything's saved, and let's click on login. And while that's connecting, okay, it's saying continue, as not done this before with this server. We continued, we've gotten everything there. So now we can observe everything that is on the instance. And if we go to where we have in PuTTY, it will show the same thing. So now the Jupyter Notebook is running. Here's the web address it is running under. We copy that address. All you do is highlight it. And once you highlight something, it will automatically copy. So it is automatically copied. All you do is highlight it. Go to tab, hit paste, press enter. And you should have been taken to it. Make sure I don't skip any steps. Perhaps localhost. No. Okay, so that should have taken you to it's not secure. Still is not taking you to. Okay. So I'm going to have to attempt to backtrack and figure out exactly where everything went wrong. But this is just the token copied twice. Okay, so we have under these security groups. Okay, inbound traffic works. Okay. One things out of that. So click on LS. Just want to say something. As you can see, we have Anaconda. Everything is right here, similar to how it is for the WinSCP. The WinSCP is just there because it allows for easy file transferring as opposed to typing in Linux codes. The next thing we also need to do is for the image classifier project, we need to put the Python notebook into the instance. So we have the file, we just download as a notebook. That is downloaded. And also this file also has a helper Python library that it uses. So just click on open and it will bring you to the helper.py file. And all I have to do is click on save that file. Not save, excuse me. Download that file, or all that is already downloaded for here. So that is downloaded. Those things are downloaded. And since those things are downloaded, we can use WinSCP and go to the folder is in. So go to my downloads, sort by what's changed. And what I'm going to do is going to select the image classifier, drag it, bring it over here. And we have uploaded the file, okay. And also the helper function, the helper Python file, drag it. And so now we have everything we need to begin starting on the instance and to make sure the instance was set up properly. Let's load this demo. So that is loaded. Yeah, we used the demo, right? Just to make sure. Yeah, it wouldn't allow us to log in for the demo. So before the tunnels, oh, the tunnel is not here. So I don't think we pressed the add button for the tunnel. I think we just typed it. Well, I just typed it in here and we did not. So 127.0.0.1, that is going to port 8888. So excuse me for that. I did not click on the add button, and the add button would have added it on here. And so we would have been able to see the port there And since we messed that up, we should click on save. Now that's saved, we won't have to do that again. And click on open. Log in as Ubuntu. And so just ls to list everything here. So you can see now we have the image classifier project, and we have the helper Python that we need. And we'll run Jupyter Notebook one more time. A lot faster than before, as you can tell. Everything's already been done. So that's our web address. All we do is highlight it, go to your page, paste it, enter, and now you will be able to have access to your instance using the Jupyter Notebook. And we have the image classifier right here. Click on it. Something you need to do, because the kernel is just Python 3, is you need to change the kernel to be able to run what you are doing. So we are using PyTorch in Python 3. We will change the environment to be able to run PyTorch in Python 3. So now that's done, we can use our GPU. So we can just run the first cell. Let's run the first cell. If everything in the first cell runs, then it should be fine. So run cell, just run the first cell. There's a star, so it's loading. And while that's loading, okay, I just wanted to show you something that I did previously through Udacity, self-driving car nanodegree, the traffic classifier sign project. So what I had to do is classify traffic signs based on using a deep learning model to classify traffic signs. So just wanted to go through that with you. I loaded the data. Actually, the training testing came from this data set. And load the data. So you have a train, test, and validation data set. And this is just some couple of NumPy functions in order to print out the shapes and whatnot of the data. So you have 35,000 training samples, 15,000 validation samples, 1,000 testing. It's an image, so it's 32 by 32 as far as pixels. You have red, green, blue as far as the color channels. 10 types or 10 classes. Okay. And that's different images. But now here is the normalizing of the data. Changed everything into grayscale. Used normalizing data. And so now it's in grayscale. It's a 32 by 32 by 1 image. We still have 35,000 as far as the training. The grayscale, the training, and the validation. images. And also something that could be of help for your project when you are training a model that you want to predict many different classes. And sometimes when you have a data set, what may happen is that it may not be as standard as this one, to where I have 10 different classes and 3,500 of each class. So that is perfect. But most of the time, you may have a lot of one and very little of the other one. What you want to do is, make sure that when you're training, you incorporate more of the class that you do not have, or the classes that are lacking as far as in number, by augmenting the data, flipping the data, rotating the data, but making sure you incorporate more images of that data so that you do have a neat class, a neat data set that will be able to train on all the classes. All right, and this is the architecture of the model. So TensorFlow uses tensors similar to PyTorch, similar to Keras. All these things are a little differently wired, but you can do everything you want to using one or the other. It's pick your poison as far as what you are using it for. But it's good to know. It's good to know many different ones in case you have to perhaps change something in one of them. But TensorFlow, PyTorch, Theano, Keras, you should learn how to do all of them. So we have our X, which this is going to be our inputs, the placeholder. It's what's going to be put into the model. We have our Y, and we're going to one-hot encode the Y, which means that, Y, if it's given as, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, we're going to change that into 10 different predictors instead of 10 different, instead of 1 through 10 as far as the classifiers. We're going to make it into 10 different predictors. And, based on the probability of each predictor, then we're going to designate which one is most likely. Our mu and our sigma. So all of the weights and the biases start off really small because we have we penalize on large weights. That's what we for regularization, right? So we want to start off all the weights being really small. So the mu, that's what the mu and sigma are for. So when we this is our first convolutional layer, for example, and we're going to be sampling weights with a mean of 0, a standard deviation, sigma around I believe it's a normal distribution. Yeah, truncated normal. So that's what that's going to be doing. So the weights are going to be exactly 0, but around it, so fairly small to begin with, and if necessary, then the weights will increase. So now we have, so this is our first layer, which is a convolutional layer, and we're going to be taking the 32 by 32 image, and the output, we're going to be sliding a window 5 by 5 across the 32 by 32 image. And the output is 5 different windows of, 6 different windows, 5 by 5. And the output is going to be a 28 by 28 feature map. And that's what that's saying. And we're going to be using ReLU to activate the feature map. And then we're going to pull. So out of those features that are there, we're then going to look at, a 2x2 grid space, see which one is the largest and take that one. And that's going to give us a 14 by 14 by 6 feature space, and then taking that and putting it into it says 10 by 10 here, but it's actually a 5 by 5 by 6. Okay, so the window we're going to be sliding over it is 5 by. The window that we're going to be sliding over is 5 by 5 by 6. So we're going to be sliding a window that can see all of the features, the back features, and we're going to be sliding it a 5 by 5 window across this 14 by 14 feature map. So, across this 10 by 10 feature map to get the result, which is a 5 by 5 by 16 features. And then we're going to activate it with the ReLU function. And then we're going to pull that layer. Wait. Excuse me. But so the output is the 14 by 14 by 6. We're going to slide the 5 by 5 window across the 14 by 14. That's going to give us the 10 by 10. The 10 by 10 by 16 with 16 different feature maps, that's going to be pulled to give us the 5 by 5 by 16. And now that we've had those two convolutional layers and pooling, we're going to flatten it. And then now we're going to have our fully connected layers. And this was actually something I did a little different than a usual fully connected layer that you will see. Is what I did is, besides these 400 features that you would have from the 5 by 5 by 16 that was pulled through the convolutional network, I also attached the features from after the first pooling. So I attached the features after the first pooling into the network. So you have 400 and you have another 294 features that you are pooling. So what that does is it takes the features it takes the output from the convolution network and plus the output from the less refined part of the convolutional network and puts them together. So, now you have a more refined part and a less refined part that has been put through the network that you are then using to determine the different values that you will get out of your fully connected layer. And this must have worked for the model at the time. Just a couple of tricks you can use as far as neural networks. And yeah, so yeah, that's it for that. Flatten that, concatenated the features. So now you have 400 and 294. So now you have a 694. And now for the fully connected layers, so now you have 694 features coming in. We're going to be outputting 120. So that's the first layer for the network activating with the ReLU. Then you have the 120, and that's going to go down to 84. And another layer with activating ReLU. And we actually have a dropout. We place a dropout on the fully connected layer of, we actually give it a holder, so I can change the dropout at will. So that's what the holder is there for. The placeholders are there for. And and then after that 84, we now add the last layer, which is the layer for our 10 predictors, and that is the network. And the rest is very similar to how Keras or how PyTorch would train the network. You have your epochs, you have your batches. We're going to be using cross entropy with L2 regularization. And you have your learning rates and your atom optimizer, your accuracy. This is a function that evaluates the total accuracy because you need a function because, of course, you are training and testing the model. You're training and determining the model in batches. So that's why you need to have a function to evaluate the accuracy. But everything is pretty similar, same in TensorFlow as it is for PyTorch, just different terminology. But okay, we're going to go through the 30 epochs. What I did actually is for the first 20 epochs, I used a learning rate of 0.001, then changed the learning rate for the last 20 epochs. The atom optimizer already do that, but I guess it's something that must have helped as well at the time. There's many different tricks that we eventually get to know going as far as neural networks. And so this is just going through epochs, playing out the validation and the training accuracy. And this is the model training. So training is getting better. It's getting better and better and better till you have your last of the 30 finishing with 0.833, which you probably could have actually stopped training a lot earlier, but this is just, and for the test accuracy, it actually has 93%, so it's not bad. It actually did a lot better for the test, but that's also not seeing whether I did not check the test batches as far as whether the test was majority one thing to classify or not. So who knows how it does exactly for the full, for each class that is there. But for 93% test accuracy, that's what I got. And that is, I guess I will conclude the webinar for right there. And answer any questions. We have 12 minutes. We're hoping people have more questions because we do to the Hangouts. Okay, we do only have 4 people that have completed it. So that means 10 of you are struggling to complete the project. I'm hoping you complete the project. All right, so is there any questions? I'll give you guys a minute. Excuse me for a second. I don't see any questions on the Google Hangouts for the webinar. Has there been any questions that were posted on Slack? I am checking Slack right now. No, there are no questions on Slack either. Okay, guys, like I've said before, We have a case where I would like everybody to complete this, but if they are not, then I understand. But like I said, everybody's busy. We have three different types of students. We have student A, didn't have a life before this. Good job to student A. We have student B and C who have families and have school and have other things and other priorities to deal with. Student B inconveniences everybody else around him. Student C falls prey to everything that's going on around him. Okay, you can be one or the other, inconvenience everybody or fall prey to everybody. All right. Well, that is it for the still no questions. Okay. That is it for the webinar for this week. And oh yeah, also what I would like you to complete up to is complete lesson 4 in the deep learning modules, which is Keras. So complete Keras by the end of next week, well, by Sunday of next week. And hopefully once that's done, then we can get into the image classifying. So we have 2 weeks to do the image classifying project. I hope we complete it in 1 week so we can just complete the next part. So the image classifying project should only take 1 week. I'm hoping everything goes well. And all right, if there are any questions or anything, just let me know. Thank you. Peace.